Yo, what's going on, everybody? This is the problem we're gonna be doing today. We're gonna solve it and state it in interval notation. First thing we're gonna want to do is we're gonna want to set it equal to 0. So we're just gonna rewrite it real quick. X plus 1, x minus 2 equals 0, and we're gonna find the lowest common denominator, which is gonna be x minus 2, and we're gonna multiply the x minus 2 over here, which cancels the denominator here. So you're left with x plus 1 equals 0 and x equaling -1. And now we have to find the domain, which is going to be x minus 2 cannot equal 0. So whatever makes the denominator equal 0, that's going to be your domain. So x cannot be positive 2. And now we're going to have 3 different test points, which is going to be at negative infinity, between negative infinity and -1, -1 in your domain, which is 2, and your domain 2 and infinity. So we're going to pick a point between negative infinity and -1, any point. So I'm going to pick -2. Over here I'm going to pick a 0, and over here I'm going to pick a 3. And now we're going to plug these x values into this the problem right here. So you get -2 plus 1 over -2 minus 2, which is a -1 over -4, which is a positive 1/4, which is greater than or equal to 0. So this one checks off. Next is over here. So we have a 0 plus 1 over a 0 minus 2, which is a -1/2, which is not greater than or equal to 0. So that doesn't work. Now we're going to plug in this one right here. So we're going to have a 3 plus 1 over 3 minus 2, which equals 4 over 1, which is 4, which is greater than or equal to 0. So this one checks off. So now we have to list it in interval notation, or state it, I'm sorry, which is going to be negative infinity, comma, -1 with a closed bracket, because it's greater than or equal to, a union with parenthesis the 2, because the 2 isn't included, and an infinity. And this is stated in interval notation, and this is the solution to this problem.